Alright, so today we're going to focus on a different type of double replacement reaction. It still has the same rules, still the same kind of thing going on, only this is more specifically an acid-base reaction. So I just want to make a note. So acids we know are going to be hydrogen, so H plus, with some anion. And bases are some cation with an OH negative. So unlike acids where it tells you at the end it's hydrochloric or sulfuric acid, this for bases is just it ends in hydroxide. So I want to go over the naming acid rules real quick. I don't know if you guys remember this, but I gave you the whole, my ride has hydraulic. So hydrogen with bromide would be hydrobromic, or hydrogen with chloride is hydrochloric. Pretty simple. Now I ate something icky. So hydrogen with sulfate becomes sulfuric. Hydrogen with phosphate becomes phosphoric. And the last one we had Sprite is delicious. So if I have an acid that ends in ite, it's going to switch to us. So if it's hydrogen with sulfite, it's sulfurous. Hydrogen with nitrite is nitrous acid. So we're going to do a quick acid-base reaction. So the cool thing about these is every time you're going to end up with water as one of your products and a salt. So we know that ionic compounds are also named salts, so that's kind of what you're going to be looking for. So if I had an acid-base reaction with, say, sulfuric acid, with sodium hydroxide, and I wanted to know what that's going to make. So sulfuric acid, I'm going to have my H plus with my sulfate, ic 8, plus, and then I have my Na plus with hydroxide. So I get H2, SO4, and that is going to be aqueous, plus my NaOH, which is also going to be aqueous. And now, just like any regular double replacement reaction, these are going to combine. So H plus and OH minus, yeah, it gives you an HOH, which is really just H2O. And we know that water is a liquid, plus, and then sodium sulfate. So I get my Na2SO4, and that is going to be aqueous because sodium is in group 1. So every time you're going to get some kind of liquid and a salt. So we get an ionic compound. Now just to balance, so I have, I got 2 NAs over here and 1 here, so I'm going to put a 2 in front of this. I have 1 SO4 group and I have 1 SO4 group. So I'm going to actually check these off just to make my life a little easier. Now, last but not least, I have my water molecule here. I have 2 H's plus 2 more, so that should be 4 total. So I'm going to put a 2 in front of my water so that my H's are balanced. And the last thing I'm going to check is my oxygens here. So I have 2 and 2, so my oxygens are all set. Just want you to take note that even though this SO4 has an oxygen in it, I balanced it as one big group and then just used the O's and the NaOH in order to balance the oxygens in my water. That's just going to make your life a lot easier if you think of your polyatomics as one unit. So there's going to be some practice problems posted for you to do. Please let me know if you have any questions, and I will be happy to help.